Telomeres are the highlighted yellow here at the end of a chromosome. The purple codes for DNA, and the yellow is simply a repeated sequence of TTAGGG repeated thousands of times. It was discovered by Elizabeth Blackburn from UCSF, and who won a Nobel Prize for discovering telomeres and also discovering the enzyme that extends or that extends the telomeres every time a cell divides.
So she says telomeres, keeping them in prime condition, can stave off diseases associated with aging. During our lives, they tend to wear down, and when telomeres can't protect chromosomes properly, cells can't replenish and they malfunction. Physiological changes in the body which increase risk of the major conditions and diseases of aging: cardiovascular disease, diabetes, cancer, a weakened immune system, and more. So, how do you keep your cells healthy? You eat a species-appropriate diet. They always forget to mention. Humans are designed to eat meat, period. There are many different types of meat, and all have been part of the human diet for thousands of years before agriculture. Generally speaking, meat offers excellent nutritional value and provides a good range of essential nutrients. The brain needs meat. Mental health benefits of the carnivore diet by Georgia Ede is pointing out how important meat is for our brain health. You have all those nutritional values. So the benefits are: it contributes large amounts of iron, zinc, vitamin B12, and all the fat-soluble vitamins. Lamb and mutton is also a very good choice of meat. Again, you have all the vitamins and minerals. Sheep graze on pasture all day, so their meat is therefore really healthy. So back to the telomeres. Red meat consumption appears to be related to a longer telomere length. So how can it be bad? It isn't. I will put the link in the description. I really find this interesting. Although physical activity levels are also important for a healthy lifestyle, no differences in telomere lengths were noted based on physical activity levels. Furthermore, no correlations between educational level and telomere were observed. Regarding diet, the researchers found that only the frequency of red meat consumption was related to telomere length. Therefore, red meat consumption appears to be related to a longer telomere length. However, the study looked at consumption frequency and not the amount of red meat consumed, although there appears to be a strong positive correlation between red meat consumption and telomere length. The result better represent a basis for further studies in larger populations. So all the fear-mongering about red meat, again, it's a myth.
And that enzyme is called telomerase. So the DNA, as many of you know, is transcribed into an RNA molecule, which then is translated into a protein. The blue, which was in the previous slide, purple, the blue is important for coding proteins. Damage, preferentially, when damage occurs to the chromosome, it preferentially occurs on the ends of the chromosome. So if you're going to damage something, let's damage something that doesn't code. So the telomeres don't code for anything. They're there to protect all the blue. They're there to keep the cell viable, to keep the chromosomes viable, to keep the proteins being produced as proteins that are still able to function well. But every time a cell divides, even if we have telomerase, the telomeres get shorter. And at some point, telomeres get to such a length that's so short that the cell stops division because it realizes that any more division, any more loss will actually start affecting some of the proteins that are some of the DNA that's coding for some very essential proteins. So the cell stops dividing. Sometimes the cell dies, and sometimes the cell enters a state of senescence. Senescence is a cell that's not dead, and it's pumping out inflammatory proteins. And this is one of the root causes of diseases of aging.
So, and what foods cause inflammation? Sugar and high fructose corn syrup, but also fructose from fruits. Don't eat too many fruits. Artificial trans fats. So better eat your animal fats, lard, beef tallow, duck fat, goose fat, even ghee or butter. Don't eat those shitty trans fat, nor the vegetable or seed oils again. Eat your animal fats. Then you have your carbs. They cause inflammation too. Only because it says here that we have consumed this for a very long time. Actually, we have been eating meat for much, much longer. There are some people that may tolerate a little bit of carbs, but I don't belong to them. For me, it's best to eat just meat. Leah Keys writes about this in her book.
Thank you. Well, it is both, some of the writing is lyrical, it's passionate, but what you are saying is so critical for us to hear now, many of us. Because what you're saying, let me see if I say it right, that the vegetarian way of eating, which many people are turning to because of climate change and so on, doesn't nurture the human being, doesn't nurture our bodies, and it's destroying the planet.
Right.
Have it right?
Yeah.
So let's unpack those two and talk to us about why isn't a vegetarian diet, which sounds like the right way to go, why isn't it good for people?
Well, there's a human template that needs certain nutritional elements, and they are not provided by a vegetarian diet. You can go back 4 million years to the very beginning of the human race, and there is no question that we were hunters. This is what we ate for literally 4 million years, and it's the reason we have really big brains. We have the largest brain of any primate, and we have the smallest digestive tract, which is to say, how are you going to feed that brain? I mean, our brains use 25% of the energy, our energy needs, and you're not going to get that out of plants. There just isn't enough energy. So it's quite clear that we must have been eating meat to get brains that are this large. And the other thing that you find in the archaeological record is that humans are long and tall and strong, and they keep all their teeth, and their bones are disease-free until you hit agriculture. And then suddenly everybody shrinks 6 inches and they lose their teeth, and their bones are riddled with disease.
Whoa.
And we have a concept, the diseases of civilization. There is no such thing as the diseases of hunter-gatherers.
So again, eat red meat. It's the meat that helps prevent inflammation. I have experienced it myself. As a vegan, there was so much pain in my body, inflammation going on, joint pain, muscle pain, back pain, hip pain, and it didn't go away. Whatever I tried, even massage, it made the pain worse. Once I introduced meat and removed all carbs and all nuts, seeds, fruits, whatever I've been eating, even on a paleo diet. Once I removed that, after 3 months, I was pain-free. All inflammation disappeared just by eating meat. So this doesn't surprise me. It makes total sense because so many people heal their bodies by eating a meat-based diet. You don't need to be fully carnivore if you can still tolerate some fiber, veggies or fruits. But for me, this was the best solution. And it's such a difference. The quality of life. It really depends on being free of pain.
There's a debate always raging in the literature. Is it really important? Is it a marker? And there's some research really showing that this is a meta-analysis of the association between telomere length and cardiovascular disease. And here it says retrospective data. So this is data, studies where I have a whole room full of you and you, unbeknownst, I've taken your blood. No, you actually have to consent, and I'll take your blood. And I'll also find out if you have cardiovascular disease at this point. Across all these different studies, there's an increased likelihood of having cardiovascular disease at the same time of having short telomeres, an 80% increase in having cardiovascular disease. Here are some prospective studies. These are healthy participants across all these different studies. None of them have heart disease, but in the future they will develop, some of them will develop heart disease. What is the risk of having short telomeres with developing cardiovascular disease in the future? Here the increased risk is 54%. Similarly, we have risk for mortality, and here's some recent figure on the relationship between having short telomeres and having an increased likelihood of early mortality. And here there's a 54% increased risk if you are short compared to the longest group in this sample of participants.
Dr. Nadine Burke wrote about telomeres in her ACE study book. Telomeres are very sensitive to the environment, which means that, like good car bumpers, they always take the first hit. Anything biochemically harmful, like stress or diet, is going to damage the telomeres, much more than the DNA. When the telomeres are hurt, they send signals to the rest of the cell, letting it know that the bumpers have taken too many hits and that the cell should respond. The cell reacts in two major ways. The first is that when the telomeres get too short, too many bad parallel parkers in the neighborhood, the cell can become senescent, which is a sciencey word for old. This means the cell retires and doesn't do its job anymore. Take collagen, the protein in skin that makes it supple and prevents wrinkles. If too many of the fibroblast cells that are supposed to be making collagen hit the road to play shuffleboard at Del Boca Vista, you're left looking a decade older than you actually are. Lots of things can damage the telomeres and lead to premature cellular aging, but chronic stress is a big one. When a cell becomes old or dies, it's not the end of the world, but if there is too much cell death in one place, it can lead to poor health. For instance, if there is too much cell death in the pancreas, you won't be able to make enough insulin, which can lead to diabetes. The response a cell can have to damaged and shortened telomeres, other than senescence, is that it can become precancerous or cancerous. When that happens, it means the ability of the cell to copy its DNA correctly has been compromised, and it begins coding for mutations that say, "keep making cells forever." This causes the cells to replicate uncontrollably and grow into a tumor that continues to grow and grow and grow. Simply put, if there is too much damage to your telomeres and they become excessively shortened, it can lead to premature cellular aging and disease or cancer. This adds yet another fun variable to the dating game. Not too far into the future, ladies might start looking for partners with long telomeres. Or basically, meat eaters. Look for carnivore partners. Research on telomeres and stress is relatively new, but we do know that early childhood adversity predicts shorter telomeres in adults, showing us the lasting imprint that early stress has on cellular aging and disease process. So there was a study, they found that while lifetime cumulative adversity significantly predicted telomere shortening, that shortening was due mostly to the adversity experienced in childhood. Adult adversity on its own was not significantly associated with telomere shortening. For each childhood adversity, a study participant experienced his or her odds of having short telomeres increased by 11%. What they found was that overall, those with PTSD had shorter telomeres than those in the control group. The good news is that even if you have shortened telomeres, maintaining healthy telomeres can protect you from further shortening. And this is where carnivore diet could be the key. One important way is by boosting levels of telomerase, which is an enzyme that can actually lengthen the telomere. This was an excerpt from this book.
The biggest killers in today's world are heart disease, cancer, and type 2 diabetes. And sugar feeds these diseases like wildfire. I took one of my clients, Ryan, to meet my doctor to show us the effects of sugar on the human body. We were shocked by what we discovered. Hey doctor, how are you?
Good, Ryan. Good to see you.
Great seeing you. Thanks for having us in.
Hi, Jorge.
And tell me how many pounds you've lost now.
I've lost 47 pounds,
And how much sugar you've been consuming about?
15 grams of sugar or less per day.
Let's do it.
So let's do it.
So we first drew Ryan's blood in a healthy state, and then we looked at it under a very powerful microscope.
This is what you want healthy blood to look like. All of the cells are individualized. There's no clumping. You're developing energy. The red blood cells are bringing the oxygen. If they're clumped together, they can't bring the oxygen to your tissue beds.
Right.
So that's important. That is about as healthy a picture of blood as I could ever see. So this is someone who's really cut down on their level of sugar intake. We're gonna be over this thing. That's right.
All right, you guys ready to go eat? Come on. This is where the kitchen's at. So now it was time to eat. So we started to look at some options. And what Ryan ended up eating was just some simple stuff that most Americans would eat on any typical morning. Things you would find in your house and things that parents would be happy to give to their kids. Nothing too crazy, really. Just everyday food. It didn't really look like Ryan overloaded on sugar, but in that course of that small 10 minutes, he had almost 200 grams of sugar.
It's a nice snack. Let's see what happens to the blood.
All right, well, I'm excited to see this, Ryan. What do you think? What's going through your mind right now? Well, how are you feeling? What do you think your blood's feeling? I mean,
Well, let's see. I don't know, I guess it feels a little tingly up here because it's, sugar at levels that I'm not used to doing anymore.
Ryan, after ingesting 200 grams of sugar, within about 15 to 20 minutes, we take a second sample of your blood. And what we see is rouleau, that's a French word meaning stack of coins, where you've lost the ability to have your energy manufactured in the body. You can no longer bring the energy to your cellular beds. You also have something called spicules. These are platelets which have mutated from their normal disc shape to needle-like projections, giving appearances of cracked glass. There are heavy proteins in the blood, and it slows the liver down due to much fat that develops in the blood.
so when we have this stacking of, I mean, I kind of, don't you think they look like caterpillars?
Look at caterpillars, and the sugar actually does convert in the liver to fat.
Yes, right.
That's what's happening.
So it's like gluing it together.
Gluing stress, arrogance, or ingested as tremendous amounts of high fructose corn syrup, along with all of these synthetic chemicals like sucralose, which is Splenda, aspartame. These are toxic chemicals, and their cells are being held together by duct tape. And they don't know it. They don't know it.
And when
this reveals a very powerful image of what happens to you. This is very
What
powerful.
do you think about this, Ryan? When you see this, I mean, what do you see when you look at yourself like caterpillar?
Well, to look at it as before and then now this, I'm just in shock. And before I started cutting out the sugar, I would imagine my blood looked like that constantly.